Okay, we're going to be discussing a special type of factoring, which is called the difference of squares. There are more types that we can discuss, but this is the one that we're going to be discussing for now. So the difference of squares is a squared minus b squared is a minus b times a plus b. And it's the difference of squares because this right here is a square, this is a square, and the difference is a subtraction. So hence difference of squares. So the goal is to look at these problems and understand that they're of the form something squared minus something squared. So what I'm going to do here in this problem is I'm going to convert the 4 into a 2 squared and use our exponent rules. And our exponent rule says that if I raise an exponent to an exponent, it can be written as a multiplication. So what I'm saying here is that 2 times x squared is written as 2 times 1 times 2 times x to the 1 times 2, which gives you back the 2 squared times x squared. So this is something squared, and the second part, 25, can be written as 5 squared. So if you look at this and you compare it to our equation on the top, just a squared minus b squared, really it has a parentheses squared minus b parentheses squared. So our a here is 2x and our b is equal to 5. So replacing this into the other side gives us 2x plus 5 and then 2x minus 5. This is the difference of squares when it's in its factored form. Now, I do want to say that this isn't required to understand or know that this will come out to be the one on the right. Because if you just factor it by guess and check or factor by grouping, you will get the same answer. However, if you can see this offhand, this would be 10 times faster because you wouldn't have to worry about guessing and checking at all. So let's go ahead and do another problem. So we can see that not only can you change the numbers to have squares like we did here, but we can also change the variables to be represented as squares as well. So this one can be rewritten as m squared squared minus n squared squared. Because again, exponents raised to exponents multiply. So a is this one, b is the n squared. And plugging into the second part, we get m squared minus n squared times m squared plus n squared. Now, you do need to check, remember, because when we're factoring, we need to factor it completely. So this right here, that's another difference of squares. So you have to continue it down one more step as m plus n, m minus n, and then the last part which we didn't touch is this one. And this first part is a difference of squares which gives you value. Because a here is m and b is n. Okay, so one last problem. Given by x squared minus 12x plus 12y minus y squared. Now this problem, if you look at it, right, is a type of problem where we have four terms and we want to factor it by grouping. So what we're going to show is that the difference of squares doesn't have to happen at any particular time. For example, we did a difference of squares in the very beginning here, in the very beginning here, but it can also show up later on in the problem as well. So you want to factor the way that you normally do and then apply difference of squares when it applies. Okay, so this next problem, 4 terms. So we're going to try it by factoring by grouping. So the first 2 terms here, and then the second 2 terms will be grouped together. So we can factor out an x for the first, and we get x minus 12. And then what I'm going to do is I'm going to factor out a negative y for the second one. So we get negative 12 plus y. But addition is commutative, so we can change the order of the second negative 12 plus y, and we can rewrite it as x times x minus 12 minus y times y minus 12. Now, in the very beginning, it looks like this would have worked, right? Because we got that variable minus 12 on both of them. But they have to be the same, right? So because one has an x, one has a y, this fails. And there's nothing else I could do to change the fact that there's an x and a y, one in each. So this grouping fails. And what we need to do is we need to go back to the top and try and rearrange it a little bit. So I think the natural grouping for these four terms is going to be grouping the 12s together. So let's go ahead and rewrite that as negative 12x plus 12y plus x squared minus y squared. And can we see that from the first two terms, the two terms that we're going to group together now, just these ones, that we can factor out a negative 12 so that we can get x minus y. Now you can also factor out a regular 12, that's fine. So let's go to the other one. Notice that in the second grouping here, this x squared, y squared, that we don't have a GCF, right? Like we can't pull out a 12, we can't pull out a 1, or sorry, a 2 or 3. There's no variables in common, so there's no GCF that we can pull out. But we do have a property which allows us to factor that, which is the difference of squares. So the difference of squares here is going to give us x plus y, x minus y. And the goal of grouping was to find a factor that was in common with both of those terms. So see here that we actually have a common factor. So that allows us to pull it out to the front. And remember, whatever is left over gets written in the other part. Now you can rewrite this if you want as x minus y times x plus y minus 4. Either way is